That was not the place for it to be. What? Doesn't recognize a PDF. What have these guys done to this machine? This computer. Did we only have reader on here? Do you remember? I thought we had the real deal.
Yes, the one that you can make changes on.
Yeah. I think this is the school's load on here. Oh well. Life goes on. Yes, and my favorite touch mode. Where was it, under properties? Oh, come on. Preferences. General. No. But we have to do that every time, so remind me. That's pretty big. So what'd you do over the holidays?
Stayed most of the time here.
Yeah? Did you notice I got a haircut like yours?
Yeah, I see.
What'd you do, Paul?
Went back to Thailand.
Went back to Thailand. Yeah. When are you planning to go back to Thailand this year?
No,
You're not?
no.
Okay.
I plan not to go back until February.
So when do you plan to go to your summer job?
What?
When do you plan to go to your summer job?
May 12th.
Sorry?
May 12th.
May 12th. You know why I'm asking him all these questions? Because he was supposed to do the grading in 620 and he left me. With that stinking problem number 2. You're going to pay for that. He made up problem number 2.
The one,
With those crazy functions.
yes. The algorithms, gamma stuff is the one.
Yeah. That was my part, but the crazy functions were his part. Did you know they were going to break it? Did you know that those, one of them was a spike, right? One of the equations that you put in, it had a jump in it. Let's just put it this way, now that the students know that you did it, they're going to want to kill you, not me. So, 7. I'll give it another minute. Give me some knuckle. All right, I'm Tom.
Preston.
Nice to meet
How do
you.
you?
You the fellow's been emailing?
Yes, sir.
Yeah, good. You know this is the handicap desk, right? You got to have one. That's why it's bigger. And
Yeah, I just saw this on.
I like it though. I mean, I would sit there too if it was me. I'm Tom. Nice to meet you. Is this a bow or Mickey Mouse? It's like St. Louis. I'm Tom. Tom. Timmy? Yeah, I guess. I'm Tom. Strange name. Ah, Helen and Natasha. Now if we only had Boris and Bullwinkle. You guys know Bullwinkle? Yeah. Okay. Santiago, can you do Bullwinkle for me?
I don't know what that is.
In Spanish? Hi there, rookie. No? You didn't watch that as a little kid?
No, I don't remember that.
Wow. Maybe they didn't have TV in Comodoro, huh?
I was in Ecuador when I was a kid.
Where were you?
Buenos Aires?
Yeah?
Yeah.
With the Peronistas?
When I was a kid, they were military.
Yes, I know. Life's tough, man. Okay, so what's the number one rule? Don't ever do anything until I tell you to. That's just generally speaking. If you take another class from me that doesn't have just one assignment, don't. Whatever I say in class is all good and fine, but until you see it in writing, don't start. Would you agree with that? Would you agree with that? Yes. Okay. The one thing I am going to send you a note on, since we've got so many people, is I'd like to get a resume from everybody, and so I'll know what you're. Yes, you too. And I'll send you a note. Don't worry. I need to. It may be a couple of days because they don't fix the aliases. I can draw off a howdy, but then I'll invariably miss somebody. And unfortunately, I have to communicate with you via your howdy email. So make sure it's. Is it howdy or is it petty? Petty is the. I don't know. Whatever. I'll use them both. So just make sure it's forwarded. You know, there's no way you can read this, so let me blow it up. Sorry about that. I just thought I would conserve the space. Actually, let's just cheat today and bring the syllabus in. Okay, so this is probably the category of one of the best or one of the worst classes you're ever going to have. I presume everybody today will hope it's one of the best. It's going to be the study of unconventional reservoirs, and I have to admit that I'm still having sort of a slow start. My brain process isn't quite aligned with what I want to do, so we're going to kind of jump around a little bit. I've got a really nice outline, and yes, I'm going to try to stick to it. But the reality is, there'll be things that I want you to take a look at and things I want you to do. Do you guys mind give me a little quick background on each one of you? I know you're probably uncomfortable talking about yourself, but yes, I know you're a production engineer. You're not going to correct me?
Reservoir engineer.
Yeah, okay.
Preston, I'm pursuing a master's in geology.
Okay. You're not the guy that sent me an email today, right?
No.
How'd you get in? Just did I?
I had actually sent you an email asking
Okay,
if that was
no problem.
appropriate.
Is it really a block?
Well, yeah, we have to wait until all of the petroleum engineers decide not to take the course before we can
For grad?
get it.
Who does that? Your side?
Yeah.
Or
Suzanne Rosser. just
I'll send her.
email.
Yeah, I'll send her a note because.
I'm already in the class.
Yeah, I know, but I'm getting a backlog of people from geology and geophysics wanting to get in, and they said there's some sort of a block, and
Yeah, I think Alice just told me I had to wait for the.
I'll send her a note. Okay. I don't think there's any problem with this one. And so background's geology
And I have a geological engineering degree
from,
the University of North Dakota.
okay, it was either that or Oklahoma. So. How's things in North Dakota right now?
They're all right.
No, they're cold. You're supposed to say the ground's frozen.
Oh, I like the cold.
Yeah?
So,
So you sleep in the refrigerator or something like that?
sometimes
Yeah. How can you stand it?
I'm used to it. If you're born there, you don't know the difference.
Okay, we'll come back to that theory later. So did you work?
I had a few internships, but not with oil and gas companies.
Okay. What'd you do?
I was working with geothermal energy, so I was just working with the research group as a part of the university, and then I did a co-op with the Energy and Environmental Research Center in Grand Forks.
Okay.
I was looking at thermal maturity parameters in the Bakken formation.
So you're pretty well versed in petroleum geology.
I think I am, but there's always more to learn.
So at the end of the course, there's a movie that you have to make for me. Okay. And so one of the students last term, they did a record 97-minute movie, and I listened to every word of it. You know, and it was outstanding. Did I mention he was a geologist?
No.
Yeah. Preston, do you know how to tell the difference between a good geologist and a bad one?
I don't think so.
Me neither. The good ones seem to never shut up. That's my own joke, by the way. So you got to talk more, man. You got to come out. You got to convince me. So this movie, we had one guy who did 97 minutes, and it was actually like I needed popcorn and a drink because it was excellent. And then I had somebody that did 9 minutes, and that was a little disappointing. So I won't go into that. But the way this is going to work is we'll prepare a paper and we'll prepare a presentation, and you'll do a WMV. I've never asked you to release this, but I probably will, and it'll be totally voluntary if you want to or not. But I think we're to the point now where you're going to need examples, and these are there's a couple of ones that are pretty good. Just so we're all on the same page today, the samples that I'll give you at presentations, I like dense material. I don't like one figure and no words. I like you treating it like you're giving it at a technical presentation. It's not just a personal preference, it's a reality. I mean, this goes in as a experience that's going to try to build some part of the literature. You want to keep this together. Do you look at search and discovery articles periodically? Do you like them?
Yeah.
What are these guys don't know, so what are search and discovery articles?
Just like a collection of scientific literature.
Okay.
It's compiled together and peer reviewed or not.
Or not. Maybe a paper, maybe an extended abstract,
Yeah.
maybe a presentation. What if it's a presentation and it's just pictures and no words?
There's nothing really to go off with. Yeah.
Not really going to be very helpful, is it?
Yeah.
So I got one data point. I got Preston. He understands. And I'm not suggesting that Preston would only give me, a picture and no words, but I'll walk you through this. We're going to have a lot more explanation on what Tom wants. And if this seems like it's fresh in my mind, it's because it is fresh in my mind. This is your project, and I'll say that it's pretty wide. Any aspect of unconventionals that you want to try to state your expertise on, that's fine. It'll be better than it sounds. And this year, I'm going to ask that you clearly document your articles, like your papers, your search and discovery articles, whatever, presentations, etc., as zip files. Put them all, give them a nice name or some sort of description. Put them all in a folder, zip them, and provide that as well. Why? Because we're building for posterity, and we want to give other people this material too. What's a file name convention that would make sense? Like maybe AAPG Bulletin 83 point something like that in the file name, so people know what they're looking for. We'll work on that. Okay. All right, Wahid, Petroleum Engineer.
Yes, sir. Ali.
Okay.
Yeah, I did 3 years at the Qatar campus and then senior year here in College Station. And now I'm doing a master's, second semester.
Okay. And tell me more.
I'm from Egypt and I did one internship 1 summer ago in Qatar with Shell. And this is my first class I've taken with you.
How was Shell?
It was really good.
Yeah? What did they have you work on?
I was working on production forecasting. So basically, they were having problems using the separator, so I was just building a model or an Excel file for them to do that.
Which field?
That was a North field.
Oh, okay.
Yeah.
What's the North Field?
It's a gas reservoir.
Well, you got 10 other people in here who've never heard of it.
Oh, it's a
It's not just a gas reservoir,
dry gas reservoir.
and it is the
Largest one
in the
in the world.
correct. Okay, thank you. All right. How big is it?
I don't know the answer.
That's the right answer. They don't know either. There's a line right down the middle of it. What's that line?
It's a border line between Qatar and Iraq.
Iran, yeah. Okay. They estimate it's 1,000 TCF. How long would it last at current production rates? About 400 years. Why aren't the Qataris drilling more wells? Or sorry, why aren't the members of the consortium who operate Northfield not drilling more wells?
So that they can outproduce
No, they're not. There's a moratorium.
oh yes, sorry, I don't
Why are they not drilling more wells? Anybody?
I mean,
They don't need to.
they don't need to.
How many people are in Qatar?
Qatar is 220,000.
220,000
Yeah.
citizens.
Yeah.
And how many people live there?
1 million, so it's 20%.
Yeah. And it has, what's its GDP per person?
Around $80,000.
US dollars?
Yeah.
Is that a lot?
That's the highest in the world.
Yeah. So they don't need any more money.
I mean, you always need more money.
Oh, you do? That was good. You think on your feet, well, I won't torture you quite the same. Tell us what your background is.
I'm the PhD student in the geology department, and my research is currently in the base modeling program and the Reservoir.
Okay, you're the one that sent me a note
Yeah.
from Dr. Pope, right?
Yeah.
Okay. Are you comfortable being with a bunch of engineers?
Actually, I got my bachelor in petroleum engineering.
Okay. You're undergraduate.
Yeah, and I did my master in geology.
Okay. Where'd you do your undergraduate?
At China University.
Okay. Where's that?
It's in China.
Yeah, I got that.
Um,
Oh, it's in Beijing?
no,
No.
it's the other one that is in China.
Yeah. It's near Daxing.
Yeah.
Yeah. So, I was in China at an invited thing last year, and my host was from USTC. You know USTC? Science and Technology China.
Okay.
It's in Hefei, right?
Yeah.
Yeah. But it's supposed to be United States Training Center, is that right? You don't call it that?
It's a good university.
I know, it's a very, very good university.
Yes.
Okay, so what's the best thing about being a geologist? Field trip. Ah, you like that too? Hey, you like field trip? President, sorry.
I don't think it's the best thing about being a geologist.
What's the best thing?
I guess it's a debate, but probably not knowing and trying to figure it out.
So as geologists, I'm just going to ask you, like, I know my name's on the placard or whatever, but I don't see in multiple dimensions. You know, I'm very linear, kind of maybe like an idiot or something. But you guys can see in multiple dimensions, right?
I guess we try to see it.
Yeah.
Like clouds and things like that. I'm not trying to be funny, but
No.
it's an art. It's part of art as well as science, right? Good. And what are you going to do once you finish your PhD? You got to have a plan. If you don't have a plan, you'll end up being a professor like me.
That's an option.
Yeah?
Yeah.
We'll talk later. Maybe not.
I don't mind to be a professor.
Good.
Yeah. I like to do the research, so it's not bad.
Yeah. Remember the thing we talked about, a good geologist? Remember that. You guys know Dr. Ingelder at Penn State? The father of the Marsalis? He's a friend of mine. He definitely is a good geologist in my criteria. And it's being recorded, so somebody's going to play it back for him. But he definitely knows. Neither do I, by the way. So, next.
My name is Jeremy. I'm a PhD student in this department, working with Dr. King,
Okay.
integrating well testing into 3D unconventional reservoirs. So, in this class today, we what the unconventional reservoir look like.
Well test and unconventional reservoir.
Yes, it's kind of like a dynamic data integration.
What do you use well test in unconventional reservoirs?
Actually, it's pressure transient.
Okay, but what's the value of a pressure transient test in an unconventional reservoir?
Just the pressure change of the bottom flow pressure.
Okay, but these guys don't know anything about well test. This one might, that one might. Anybody else know anything about pressure transient testing? Yeah? Oh, okay, so they all do. So what's the permeability?
We're using the well bore pressure job. I mean the diagnostic plot, the pressure derivative as our objective function, and then to get the reservoir properties.
But how many, what's the normal type of permeability you're looking at?
Kind of slow.
Kind of low?
Very slow actually. It's maybe type gas reservoir.
Okay, so you still have the possibility of seeing something like a radial flow regime?
Hopefully.
Do you know why I'm torturing him with this? Because if you don't have certain regimes, then it's impossible to determine the permeability you need. And that's what all these other guys are going to raise their hands on. They'll determine it stochastic. Do you know what that means? Remember pin the tail on the donkey when we were kids? Yeah, that's kind of stochastic. Until you pin the tail on your friend's mom, you know, that kind of thing. Okay, very good. So you're going to be my go-to man on pressure transient?
Yeah.
All right, we'll see. I'm looking forward to this. Computers and stuff. Next.
I'm Majid I'm a new student here. And,
Okay, so you're Wali, you're Ali. I got it straight now.
okay.
Very good.
I'm a graduate petroleum engineer. I did my BS in Wisdom Plus and then I work for a year and all that.
Good. And you're ready to be tortured. You're like clay, ready to be formed. I like that. Okay, Femi, let us have it.
Yeah, I'm a PhD at the Department of Petroleum Engineering. I've worked for 3 years as a mechanical engineer.
What's your PhD?
Wellbore braking, effective braking hydrodynamics.
Bridging. You mean like geomechanics? Or?
Yes, wellbore geomechanics.
Okay. And what did you do as a mechanical engineer?
I worked as
You're not violent, are you? Because I was going to ask, I mean, don't you guys all do air conditioning systems or something? Just checking to see how violent you might be.
I worked on turbo machine.
Turbo machine. Here?
No, it was engineering.
Yeah. Because I know Dr. Child,
Yeah,
all these other guys.
turbo engineering.
We've been around too long. So you like rotating machinery and now you like wellbore stability? Are you sure you're not a geologist?
No, I'm not.
That's an awfully strange combination. I like it though. So, have you dealt with low permeability systems before?
Not
You know what, like a brick is?
really.
Is a brick, is it low permeability, a brick?
A brick,
Yeah.
middle,
Okay.
sand,
Well,
middle sand.
bricks, they're made of lead,
So
right?
very permeability.
Anybody want to guess? I mean, what's the permeability of a brick? I frankly don't know. You know, I'm not a lawyer. You should never ask a question you don't know. We could look it up on that. What's that thing called? The interweb? Yeah. Why don't we do that? You guys like Google?
We love Google.
Yeah. Google's going to rule the world. Preston, are you worried about that?
Should I be?
Good answer. Okay, so permeability of a brick. I guess we could say in millidarcies. Not Annapolis, Maryland. That's the problem with Google, man. They know what I want. They don't know what I need. That's interesting, but probably not what I'm looking for. Permeability of a brick. Does anybody see a brick? Did you guys see a number? I gotta put my glasses on. Great. This is not what I was hoping for.
That was one.
Okay, here we go. What the hell do these numbers mean? Okay, so where's brick? There it is. So it's 10 to the minus 16. Cement's 10 to the minus 20. Sandstone is 10 to the minus 13. Limestone's 10 to the minus 16. Concrete's 10 to the minus 18. So a brick is not quite, no, it's more permeable than concrete. That's interesting. I wish they'd give us the right dang numbers.
Similar to limestone.
Yeah. So relatively speaking, a brick is kind of high in permeability, I think. Here's some stuff from Australia. Anybody want to work in Western Australia? Yeah? Preston, you want to go to Perth?
It was suitable, I guess. I've
Yeah,
never
it's not cold there. Okay?
That's already just killed it.
Yeah. Perth is like the most livable city in the world, you know? But only if you got some change in your pocket. A mid-range hotel per night in Perth will run you $500 US. It's a boom town. So let's see. There's tight gas, coal bed methane. Come on, you guys got to give me some numbers.
There's a brick right there.
Yeah, I can see that. So a brick is better than tight gas. How's that? Is that good enough? So Femi, what does that mean?
Brick is,
Is good,
yeah.
and shale is bad. You know, it's difficult to get fluids to move in a shale. In fact, it turns out that we're not sure how fluids move in shales. Yeah. You know, like Star Trek, you know, they had the transporter thing. Do fluids move in shales by transporting themselves? Yeah. I don't know. Diffusion, yeah. That's one mechanism. Could it move by other mechanisms? Could it move by molecular effects? Could it do that? Or you don't know. You're studying, what, 2 nanometers apart, graphene slices with molecules bouncing in between them? So molecules, when they start to get the same size as the container, is that a good thing?
It will condense, and it will become liquid, and yes.
No, but I'm saying if you were a molecule and you were the same size as the room you're in, that'd be pretty miserable. Then it doesn't behave like a fluid, it behaves like something else. How do they get in and out? I mean, this is, you guys, this is your specialty.
Migration?
Well, generation, maturation, expulsion. When it's that low permeability, how does it get out? I mean, we know
There's a
how it
lot
got
of-
in, right?
There are a lot of papers that still talk about that. It's very widely disputed.
Yeah.
They really don't know how. They don't know the migration.
I'm sorry, could you say that sentence again? I don't know.
They don't. I don't know.
Yeah, I want to point out that that's the facts. We don't really know what it does.
Well, you can. They can trace the oil, like within the Wilson Basin. They trace the oils there from Wilson Basin up into Saskatchewan. But
Sure, but I'm talking about how does it get out of the little thingy?
There was a paper by Meissner, Fred Meissner, in 1978. He talked about. He thought it was released from petroleum generation, and thought like the microfractures will allow for some kind of.
How did the fractures occur?
I don't know.
I saw a presentation today from a company that is not active in unconventionals. In fact, I could probably say who it was. It was the largest oil company in the world, and they're getting into unconventionals. And they're trying to understand how things are expulsed, how their reservoirs were charged. And it's nearly impossible. You can't use the rock in its current state and assume that things could get out.
Well, I guess the one thing we still can't test is the idea of deep time. Because what are we looking at when we're trying to test something in a bottle? We don't have that much time then.
You guys understand what he means? The rock took millions of years to form. The hydrocarbons took millions of years to form. How did they get out? What was left? That's what.
The time constraints on migration and generation.
So it's good we had time on our hands.
Yeah.
You like this stuff?
Yeah.
You think so? So when you go back to Nigeria, you're going to start an unconventional oil and gas company? I thought you could just walk around in Nigeria and pick it up with a bucket.
Yeah, but the business is more conventional than Nigeria. So unconventional is still not.
But if you were thinking ahead, like 40, 50 years from now, where did all that stuff come from, President?
Where it all
That oil that they find in Nigeria?
You mean like organisms?
No, I mean like it came from the shales, right?
Oh yeah.
And they're below the reservoirs, right?
Yeah.
So maybe I mean, would we drill in the Gulf of Mexico to try to find the source rock?
Would we or do we?
You tell me.
I have.
Now you're from China, right?
Yes.
If we drill deep enough, do we come out? I'm just curious. Okay. So how deep would we have to drill in the Gulf of Mexico to find a shale, a source rock? You guys didn't like that. I thought you liked it. Didn't you ever try to dig to America when you were a kid? We used to dig to China all the time. You started digging a hole in the ground.
Really?
Yeah. You didn't know that?
I don't know.
Yeah. You never tried to dig to America?
No, I don't know. America, well,
We were all always right. I mean,
Yeah.
if you dig the hole deep enough, you come out in China. The truth is, you come out somewhere in the Pacific Ocean. That's okay. Okay. I'm just curious.
I don't know that much about the Gulf.
What's the
Yeah,
deepest well in the world? The Ruski's drilled is 49,000 feet. Yeah. What's the deepest well right now?
I don't know.
It's called Blackbeard. It's in the Gulf of Mexico. It's deep. It's not. It's only like 33,000 feet. It's like 480 degrees Fahrenheit. They're getting close to China. You know? So, and what do you expect to find at those temperatures?
Gas.
Nothing. Okay, but I really yes. Yes. All right. Sorry. Good job. Okay, Natasha.
Natasha.
Yeah. Are you a geologist?
No, petroleum engineer
Okay. From,
from Thailand.
that was my guess. Chulalongkorn?
Yes.
Yeah. And you work for PTEP?
I actually work for Chevron.
Oh, those guys. So you worked for Unical first?
I was hired by Unical, but
Right.
by the time I joined the company, became Chevron.
And you knew Mr. Peach?
Yes, sir.
Yeah.
He was the one who hired me.
Yeah. He used to sit across the street with me in that building. He was a strange fellow. Shouldn't say that while it's being recorded. But that's good. He chose well. He hired you.
I think.
Okay, so tell me about unconventional reservoirs in Thailand.
I don't think.
You're going to have to drill to China to find it. Where would you hit if you drilled through Thailand? Don't know. Just curious. So, what's your specialty?
Production. I've spent most of my time in production as a
Yeah.
production engineer. A little bit on reservoir, but as much as production.
You didn't know my student Montan, did you? Sent the bunk school? He probably did something else. He wasn't really interested in drawing. He was kind of, it's the wrong word, playful, is that the right way? Yeah, he enjoyed his time at Texas A&M. Good kid. Just wondering. So production engineer, looking at unconventional reservoirs, what kind of specialty do you bring to the equation? Do you know how to poke holes in pipe? And do you know how to pump sand and water and stuff like that?
Yeah,
A lot?
a little bit.
Yeah. No, I mean, but doing it a lot.
Yeah, we do it not as much in Thailand.
Yeah, but well, you have multi-stack today, right? So you
Yes.
drill vertical wells and then you stimulate multi-stage fractures. Do you have any horizontal ones?
Yes, it's for the past few years we,
But high variability or low variability?
what do you consider high?
Well, I mean, is it fractured or is it just open?
It's just open.
Yeah, so it's
Yeah, in Thailand we haven't,
like not true.
we haven't really done a lot of fracturing.
Okay.
Tried. The cost.
So you're going to learn all this, you're going to steal our technology and go back to Thailand.
That too, or I could work Chevron sometimes.
Do you know my student Valentina, the Russian girl?
I will be her for some time.
Smart girl. She was working for Chevron during Hurricane Katrina, you know? It took me a couple of weeks to find her. You know, I was worried about her, you know? I mean, you worry about your students like they're your children. She goes, you know, I'm not so stupid, Dr. Russell. And I said, I never said you were. She goes, no, my apartment on the second floor. So, no problem.
She worked on fiction.
Yeah.
Now I think she's
In Duri?
building.
Oh, yeah.
She,
But I thought she was going to go to Kazakhstan. No?
not sure. I think she moved out there.
I see. Well, I hope you got along well with her. I made her life miserable for about 3 weeks. So whatever she says about me isn't true. Okay, Alan, you're last.
Master's student here and did my
Here?
No, Marietta.
Oh, Marietta. What's the best thing about Marietta?
Small.
No, Dr. Chase.
Might be true.
Yeah, he's an angel, huh?
Yeah, he is.
He's my role model. I'll never be the man Bob Chase is. So you decided to come see us
Uh-huh.
so you can steal all of what we do and take it back to Marietta? You wouldn't do that, would you? What are they doing up in Marietta these days? Oh, they don't offer graduate degrees.
Yeah.
Did you work?
No. Came directly from undergrad.
Yeah, that's a bad idea. I did that too. You have to work a little bit so you can have some motivation. Like, you ever wake up wondering if there's an alligator in your room? You know, that's what it's like having a job. Because every day you could wake up and there could be an alligator waiting to take your job. You're wondering what I'm talking about, aren't you? But you'll figure it out later. All right, Preston, we got to get back on this. So tell me the kind of rocks you've looked at as a geologist.
All of them.
All of them? You've looked at all rocks?
Master's degree? With a master's degree, or throughout my life?
You know, my son, we had a gravel driveway, and pretty soon he brought most of it in the house because he wanted all of the rocks. So you've looked at all of the rocks?
I was looking in rock piles outside the grocery store when my mom was inside getting groceries as a kid, so yes.
I think we're going to move to saying, you looked at all the rocks? Just curious. So, do you know the difference between high permeability and low permeability?
Yeah.
Yeah. Okay. Did you know a brick was higher than tight gas?
No, I didn't.
Me neither. See, this is a sort of a joint learning experience. So you think when you go home and tell your parents or your significant other that, you know, we produce oil and gas out of things that are much worse than brick, they're going to understand?
Well, my significant other would, because she's a mudlogger right now. But
Oh, all right. So she knows about bricks?
no, but she would understand my reasoning.
Okay. How would you determine the permeability of something that's this low, that's this tight? And I understand that's a trick question because you may not have the background, but how would you propose to do it? Do you remember Darcy's law? Pressure gradient, rate, constant of proportionality, that's Darcy's permeability. Okay. But something really low permeability, extremely low. It could take years for it to come to equilibrium. How would you determine the permeability then? And I'm not torturing you. I'm looking at everybody. It just looks like I'm looking at you. You want to throw a lifeline to Helen?
Sure.
Helen, how would you do it? You remember the core lab at Marietta? Took a piece of rock, put it in the machine, went and had a cup of coffee, did a little Facebook, came back, took a number. You remember that? Okay, so what happens if we reduce the permeability of that sample by a factor of 1 million?
Won't read anything.
Why? Because it's basically a seal then. Okay. And your equipment is not sensitive enough to know that. In fact, at that permeability, the gas or the fluid is probably slipping around the sides more than it's going through it. Okay. So somebody throw me a bone. What would you do if you had to determine the permeability of something like that? Sorry?
Crush it.
Crush it. I like the way you think. You'd crush it until you had what? Dust? Think carefully. What would you do? Is she on the right track?
I don't know.
Sounds pretty far-fetched to me. I started to say stupid, but I won't say that because that would be rude. You know what that's called? It's called the GRI method. It's a paper that's about 20 years old. You take a piece of coal or a piece of shale, you crush it, you sieve it to a certain size, put it in a chamber, you apply a pressure, you let the pressure bleed off, and according to how the pressure bleeds off, you match it with a simulation, and that tells you what the permeability is. Sounds sexy. Is it going to work? Anybody? Femi likes the idea. You have no idea, right?
No, I'm not sure if that method will work.
Yeah.
By crushing, I've reduced the pore space.
Correct, but you've got pieces that are uniform size. And so the theory is that if they're all basically uniform size, and you inject into them, and then you release and let them flow out, or let the system relax, then the rate of decay of the pressure will be proportional to the permeability. I mean, there's a whole bunch of things wrong with this, but that's what's used. So, you know, when you hear crushed permeability, that's what they're talking about. Okay, so let's say that I crush you, and I take a sample and I test it, and I crush, no, that's not fair. I take a plug, no, that's not fair. Okay, so here's what we're going to do. We're going to take a piece of rock, and we're going to take multiple samples very close to each other, maybe 1 centimeter apart. We're going to crush them, we're going to put them in a permeameter, we're going to very carefully test them. How much difference would you expect in the calculated permeability?
Assuming that it's completely isotropic.
Just whatever. You know, think of a Rubik's Cube. We take all 9 pieces. Is it 9? No. 27. That's pretty stupid. Okay, so we take a piece of rock, we cut it into cubes, and we test we crush each one separately, and we test them all. Same size as Rubik's Cube. What's the variation? Okay, 10%?
Sure. 10%.
10?
90.
90.
Maybe 10, maybe 90.
90.
Maybe 10.
I want to ask a question. Will the molecules have the same particles, have the same distance?
What we're going to do is we're going to sieve them and make sure they're about the same size. We're going to put them in a cell and pack them so there's no wiggle room or anything like that. So, yes, they'll be uniformly done.
Okay. Okay, so what I can put the figure to be, the difference would be maybe marginal.
Margin. Okay. Marginal's a number. Somewhere near
Less than 40.
less than 40? Damn. I'm going to have you do my taxes. Okay. Tasha? It could be anything. I'm going to definitely have you do my taxes. Will you go to jail with me? Any ideas? So I got 10%, anything, and 90%. What do I got from you? 5%? Okay, so let's use that Google thing. Okay, not what I was looking for, but I guess I better say GRI. That's starting to look better. I need a plot of it. Throw me a bone. I know what I'll do. What's your favorite shale? getting warmer. How do they get Jaguar out of that? Come on, there's got to be one around here somewhere. Tell me another shale. Barnett? Come on. Somebody's got to have a plot somewhere. Where do they get this stuff? Give me another shale. Devonian. No, that's not a good idea. Hi. What am I not doing right here? Zimbabwe, Kenya, elephant populations. Are you sure this thing knows what it's doing? Okay, crushed permeability. Let's take porosity out. That didn't help much. Somebody give me another word. Cross plot, graph, chart. What about data? This is insane. Surely they've got to have one or two plots of this somewhere. Who are these guys? Somebody help me out here. Give me some more words. GRI method. Samples. I can't believe there's no plot. This is insane. If I keep adding words.
I remove words rather than add them.
Huh?
I remove words rather than add them.
What do you know? So what would you remove?
I don't know exactly what you're searching for, but
GRI method. We'll take the word crushed out. Take semilog out.
is this the GRI method only have on X and Y porosity and permeability?
Yeah.
So you can take those out too.
Okay, so something like this. But so which one would you take out? GRI method sample data plot? Oh, that worked. Good idea. Let's try Haynesville. So you wanted me to take stuff out, right? This is nuts. There's got to be a cross plot. I'm taking words out.
Can you use Google Scholar to look for a paper instead of just 20 knots.
I'll do whatever you tell me. You gotta be joking. Come on. This is embarrassing. Anybody got any other ideas? This is insane. There's got to be a cross plot of this, Andy. So you want me to go to Bing? You really want me to do that? You want me to violate all my principles?
It's just a suggestion.
Throw me a bone. The hell, uranium? Where does it come up with this stuff? Did you find anything yet? Is there a better search engine? I mean, this is true, but I want a cross plot.
I have something here. Significant disparities in the porosity and permeability values reported by different labs
What about
that use the
GRI?
GRI cross method.
Just GRI method.
It is a comparison of cross rock porosity and permeability.
Now, I'm looking for an image, though. That was what we're trying to find. Do you have an image?
Yes.
Let's see.
Is that what we're looking for?
More or less, it's that one. So this is in-grain. What did you tell it?
Research was GRI, crush rock permeability, and porosity. And I didn't look on images, but on web. On the web. There is a
Well, here it is. But it doesn't show the distribution. Must see photo. Oh, that's not going to help us. This is the paper, though, the original paper. Come on. What else you got for me?
well, the address of the PDF that I showed you is ingrainrocks.com.
Yeah? Here we got some stuff in Argentina. Where are you from?
Argentina.
Yeah. There you go. That's good enough for me. And it came from Exxon. Five different labs using the same technique.
More than 90%.
Comments?
Is there a better way?
There's pulsed permeability. This is fast. You crush the sample, you prepare it, you put it in the device, you run it, and you get a measurement. Like I said, and it's a regression. It fits the model to it. It gives you a permeability. But pulse permeability, where you pulse, send a pressure pulse through the rock and do a pulse decay, that's also a history match approach, and you determine the permeability from that. So pulse permeability is generally thought of as a lot higher, but pulse permeability there's a couple of problems with it. One is fractures. They'll completely obliterate, because the pulse will go straight through it. And the other is any leaks in the system. Any kind of leak in the system will cause the number. I mean, obviously, anything would have a problem with leaks. But what do you think? Interesting, huh? So what they're really trying to get at here is what can you use to estimate permeability. And the whole point of this discussion was that if you look at the methodology that's considered the standard right now, which is this GRI permeability, and he says here it takes about 10 minutes. And then they work their way down to explaining other systems. But there's your results. Now, the one I was talking about is a cloud. It looks like this. There's a cloud of points going across. There's hundreds of measurements on different samples, and there's just a cloud. So, Femi, if tomorrow you went to your bank account and you were supposed to have $10, but you had 100, would you say anything? Okay, so if you had $10, or sorry, if you thought you had $10 and you only had one, would you say anything? Yeah. Okay, so which is what I'm really asking here, because these are scales of 10. So this one's 10 too high, and that one's a lot more than 10 too low, assuming the one in the middle is right, which probably is a bad assumption. So where we're at permeability-wise is way down here. In fact, we're at this point, 1 times 10 to the minus 6. This is, sorry, that's 1 times 10 to the minus 5. We're actually below this. So, we're going to have a hard time with this. Okay, I'm going to shut up now and go back to the syllabus. So, we introduced ourselves, we talked about various things, and you're going to write me a nice report on a topic. Do you know what your topic's going to be yet? But you work tight gas.
Yes.
But now you got to work tighter. Okay, got to be tighter than tight gas. What is the definition of tight gas?
Permeability?
Yes.
0.1, below 0.1.
Below. And then what's the cutoff?
I don't know. To shape?
Yeah, I mean, it's sooner or later. What's the limits? Probably 10 to the minus 3. So somewhere between 10 to the minus 1 and 10 to the minus 3 millidarcies is tight gas. And then where are shales? Probably 10 to the minus 3 to 10 to the minus 6. Has anybody seen below 10 to the minus 6 permeabilities? I have. That's pretty low. The numbers start getting really edgy. Now, as a geologist, you're taught that a reservoir seal is what? Maybe 0.1 millidarcies, like he was just talking about. Maybe 0.001, or sorry, 0.01 millidarcies. Yeah. Did you study all this with capillary pressure and determining seals and that sort of thing?
Yeah, but I'm not sure about the exact number.
Okay. Well, that would be a normal type reservoir. So what's the seal here in a shale? The shale is the seal. All the stuff's trapped inside it. It got out, right? Some of it got out, we think, because it charged the reservoirs around it. Somebody pointed out in the discussion today, how do we know what's left? It's not X, it's not 1, it's 1 minus X, whatever escaped. Let me ask you another question. And he's the only one in the room that can answer it, so he's not going to answer it. Ready? What's critical state mean to you engineers? Let's ask Debbie. What's a critical point in a phase behavior? Like pressure, volume, temperature. What would be the critical point? What would it describe?
When it's changing phase.
Right, from gas to liquid, for example. Okay, and then there's a special point that's called the critical. Over here it's liquid, over here it's gas, over here it's something we don't know what it is. These are all above. But then when we drop below that, we get something that happens. Do you have any idea why most of these shales that we're finding are very, very close to the critical? I mean, you've seen dead oil, you've seen dry gas, you've seen dry gas in Doha, you've seen oil in Dakin, you've seen gas and oil, you've seen whatever Pakistan has to offer. What have you seen? Lots of dry gas. Yeah. Light oil. Okay. But what happens, why would something be at the critical? Tell me, you know.
Not sure. The thinking is that the envelope is small.
It's not a bad guess. I don't think it's right, but it's not a bad guess. Think not small envelope, but small volume. If all those molecules are compressed in there really tightly, what will happen? When we think about nanovolumes and the work you're doing, we're going to cause it to be at the critical state? Is that how you think about it? We're not sure. That's another one of those not sures. But if I drill a well where you are, and I get gas condensate, then I come over 5 kilometers and drill a well where he is, and I get volatile oil. We don't deal with things like that in this business. How did that happen? How can I, and if I drill a well in the middle, it could be either one. And they're all very close to each other. They're all in the upper 40s on gravity. You know, they're all about, well, they're all at the same temperature, same pressure. What's going on? Now, I know I lost you, but this is an engineering problem. Why is it an engineering problem? How much is a barrel of oil today? You got to know this.
How much is a barrel of oil today?
Yeah.
I don't know.
Ask Google. You don't get up in the morning and ask Google?
96.
I think it's 93. No, 92. Sorry. Okay. What's gas price today? It's 427. BTU equivalent of gas to oil. It's a 6-to-1 ratio. Okay. So what kind of price differential is that? If you multiply gas by 6, you get 24. Am I doing that right?
Yes.
And then divide it into 90.
More than 3 times.
Oil is 4 times more valuable than gas. So you want to be an oil company or you want to be a gas company?
Oil.
So why are shale plays profitable?
Because oil.
Because they're producing oil. What different colors does the oil have?
Many. I've seen orange, green, black,
Yellow,
yellow, white,
clear.
clear.
I've seen them all from the same field.
Yeah, from the same field too.
How did that happen? No, it's just how it's made. You know. Okay, we're going to talk about that too. Somebody in here might want to work on phase behavior for their project. You know, I put a little bit of that in the syllabus. You guys ever heard of dimethyl ether?
What?
Dimethyl ether. Never heard of it? Why is dimethyl ether so popular?
MTB, something to do with MTB, gasoline additive.
Dimethyl ether can be derived from almost anything. So where did dimethyl ether take off, Miss Ang? Took off in China, because you can make it out of garbage, plant matter, everything else. What's the molecule look like? They have a picture of dimethyl ether molecule. Come on. You guys think I'm wasting your time, don't you? This is what it looks like. What's it kind of look like?
H2O. Sorry.
What does it look like?
Mm-hmm. How many hydrogens does it have?
66.
Yeah. What else has 6 hydrogens? Sorry? Benzene?
6.
I was thinking of something we use. How about ethane? Okay. So it looks kind of like ethane. It's got an oxygen in there, though. So it's probably got not quite as much energy content, but it can be made out of anything. In your career, are you going to see fuels like this? What if you could pull up to the pump and run your car on this? Would you buy it?
Yep.
Just cheaper.
It's a very low caloric value. If the caloric value is very low, then it is not economical.
It wouldn't be economic. But if the feedstock is free, then maybe it would be. I'm just going through all this because you're going to look at a lot of different things in your career, a lot of things you didn't expect. What's the magic in refining of hydrocarbons? We already said oil's more valuable than gas, right? So what if you could take gas and turn it into oil?
With the rich person.
Are you sure?
I think so.
If you had a virtually unlimited feedstock, in other words, you'd have to have really cheap gas, right?
Yeah.
Where do we have cheap gas? Oops. How much do they pay for gas in England?
In where?
In England,
$10.
more like 12. Okay. What do we pay? 4 per MCF. Okay. So if you could take $4 MCF and convert it to a fuel that you could sell for
24.
X dollars a gallon and transport it. Yeah. Unfortunately, that's not easy. Did any of you pay attention to what happened last month with Shell? They were going to build a $12 billion plant in Louisiana.
Oh, it got cancelled.
Why?
It's not economical.
Is that right?
I think it's not economical.
Okay, you think.
Because
Why would it not be economical? You're sitting on top of potentially 10 to 20 BCF a day of natural gas from the Haynesville that you could easily transport to this thing for conversion.
too many supply, not much demand.
Not much demand?
The plan was to produce this fuel from natural
No,
gas.
forget it. Forget this. But It was to produce diesel and gasoline from natural gas. Sorry, yes, you can also produce this easily from natural gas. And I'm not sure why you would, but you could. Let's see what Shell said. $20 billion is what it would have cost. Okay. So it's a huge jump from 12.5 to 20. Okay. And they said Shell didn't offer details on why the plant blah, 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 right? Did they fail to mention something? Sasol is building one in Lake Charles, where I grew up. I was there last week, and I asked my cousin what life was like there because Lake Charles lives or dies, just like North Dakota does, by the oil price. They said, we've been saved. Sasol beat them to it. You've lived in Qatar?
Yes, sir.
What do they produce in Qatar?
GTL,
And who owns the plant?
Shell.
And yet they can't make money in the U.S. with virtually free gas.
They were hardly making any money in Qatar too.
Yeah, well, that's true. But probably because somebody beat them to it. Interesting stuff, huh? Okay, let's get out of Google. All this stuff about policies and procedures, just, you know, turn your stuff in when I tell you to. By the way, when is that? Turpon? I learned my lesson with you. The due date will be 22nd of October, or October, gee, Freudian slip. It'll be the 22nd of April. And we're going to spend some time together working on this. I'm not promising it's going to be fun, but we'll spend some time working on it. Okay, so this week we'll talk about geoscience. I'll get a presentation together on Wednesday. We'll go over that. Unfortunately, I was supposed to be out of town next week, and it looks like that's going to happen, and then I'm out of town for a very, very long time. But we'll deal with this with videos, and I'll transmit to this machine, and you'll see it here. I do have one favor to ask, Santiago. What is that favor?
I don't remember.
When we're doing it by video,
Yeah.
speak loudly!
Ah, yes.
How many times did I tell you to speak up?
Many.
Okay. Femi, what does that mean? You know what this is?
Shot collar?
Yeah, exactly. I don't even know how you turn it on. Power. Okay, so the little blue light is on. What does that mean? What does that mean, Femi?
Speak to the mic.
That's right. Do you like Darth Vader? Darth Vader? Luke, I am your father. No? Okay, so Turpon, stop smiling. You're going to pass this around? Let's see what your voice sounds like.
Darth Vader voice? Darth Vader voice?
Say, I love Mr. Spock.
No, I don't love it.
Yeah?
Hello? Hello?
Mr. Bond? Goodbye, Mr. Bond. Is that what you mean? So which one is your favorite James Bond film?
Hello. Hello.
Hell.
Yeah. And if you don't speak into the mic, what happens? I push the button and it explodes. So, Femi, which one is your favorite?
County Coconut.
You only live twice, right? Did I turn it off? You didn't like You Only Live Twice?
I've not seen it.
You've never seen You Only Live Twice?
I've not seen it.
That's your assignment. Okay, so speak up and be gentle with me, okay? I'm 1,000,000 miles away, so be patient. What does that mean? Yeah, think about me. It's always about me. It's actually always about you. But if I can't hear you, you're going to hear me yelling at you. How many failures did we have, Santiago? One or two
Well,
during class?
What do you mean with failure?
Last semester, transmitting.
Yes. One, I think.
One major failure, yeah.
Yeah, the rest were okay.
The rest were acceptable. Okay. And I'll make a backup video from my side, and I'll mount it on the server. In April, though, we have fiber optic coming to our house. So we'll hopefully no longer have these problems. Okay, so we'll also talk about petrophysics, non-laminar and laminar non-Darcy flow, clays. Do you guys know anything about clays? Did you study clay? No? No? No other geologists? You got clays in Thailand, right? Yeah. I mean, if you read the literature, clay was the devil in 1978, 79, 80. There were lots of publications on the effect of clays. And then what happened?
Someone said it.
We just said, for good. You know, we'll frack through it. Oh, sorry. We will hydraulically fracture the reservoir and overcome the impediment to flow that clay represents. How's that? Was that effective? Then we'll talk about tight gas, and then we'll talk about some processes for integrated reservoir descriptions. And I really like this work. I may ask Rushing to prepare a video. I don't think he will, but he might. He might prepare a presentation for us. I'll see if he'd be willing to do that. He did a phenomenal job with this, and I'd rather have him explain it than me. Then some information on reservoir performance, and I'll keep it at a high level. You're not going to have to know the math or that sort of thing. There will be some weird plots and that sort of thing, but I promise. Oh, you've got a geological engineering degree, right? You said that, yeah. So you took physics and thermo and all. I know you're like going to jump out of your chair and kill me, right? But
No,
there's some people that have taken this that don't have any engineering background, and I promised that I wouldn't hurt them. So, but if we end up with people who all have an engineering background, I don't feel like, you know, I feel like I can talk about the details here. But, and then reserves estimation. Do you guys remember Y2K? Yeah.
What? Yeah.
Y2K, the year 2000. Yeah, the world was going to end, right? So we spent billions worrying about it. The same thing's true with reserves. You know, we spent a lot of time worrying about reserves for shales. I'm not going to do it, but type reserves for shales in Google, and you'll get some very interesting articles coming up. Why don't I care?
Because you don't know on the reservoir.
Are you sure you want to be a nightclub comedian?
We don't know the recovery factor.
Why don't we care about reserves, class?
Why do we care about reserves?
Why do we not care about reserves?
Because it's very inaccurate. It's very inaccurate. Even for professional wells.
With development techniques.
Sorry?
Can be enhanced with development techniques.
Think like a cowboy. Okay? You're going to have your own company. You're going to create shale gas or shale, liquid-rich shale exploitation company. I don't even know what that acronym spells. Okay? You're going to borrow $500 million from a bank. You're going to go buy part of a field. You make back all your money in 24 months. Do you really care about reserves? No. Do you know what the data tells us? The data tells us you shouldn't be estimating reserves until you have 18 to 36 months of data. Because prior to that, we only see transient flow. Let's explain transient flow to Preston. Okay, I'm a pressure pulse. I'm doing my own thing. I'm walking around. Did you take pressure transient test? No. Okay. And then finally, what happens, Preston? Bang, I walk into the wall. But before I hit the wall, do I know it's there? No. So if this room is a tank and there's a well in it, and prior to that pressure distribution hitting all the walls, what are the reserves? You could say, I don't know. But from your information, what are the reserves? It's infinity, because there's no response. Okay? So for the first 3 or 4 years, all these shale wells, they give an infinite acting response, which means what? If you extrapolate their behavior to infinity, you get a really big number. Now, if you take that to the bank, you think they're going to give you some more money? Or are they going to shoot you in the head? 5 years ago, they would have given you more money. Now they're going to shoot you in the head. No, I'm joking. They won't shoot me there. But there's a lot of work being done on reserves. And if you want me to tell you that I'm an expert at reserves, I'm not going to say that. I'll say I'm an expert at production forecasting, which means I don't really care what reserves are. But what are reserves for production forecasting? Turnpike? The area under the curve. Okay. See how I get away with that? So I don't declare myself a reserves expert. There's a whole society devoted to reserves, the SPEE. Okay? It has hundreds of members. They're in evaluation companies, they're in major companies, and so on. What's their job? Book reserves. Why? Because as a public company, you're valued on your reserves. Right? Is Tech Patrol valued on their reserves?
No.
Why?
It's not public.
Who'd you work for? Oh, not Petroleum. Shell? Did they have a little problem with their reserves?
I don't know.
You don't know. Yeah, why did they have a problem?
When?
Why? And when?
The chief.
2004.
Yeah.
Why did they have a problem with reserve? Preston, you don't know? Well, they had 2 problems. One is they were a little aggressive, and 2, they declared some things, reserves, that weren't on production. And reserves people are accountants. Okay? So if I have an asset that I don't have monetized, can I claim it? You don't like me talking to you, right? I'll make you uncomfortable. So let's ask Femi. I have a reservoir offshore Nigeria. I've got wells in it, but no production. I've tested them. I know they'll produce. How much is it worth?
But I think I can count them as reserves.
No, sir.
Once I know that
You can count them as, what is it, probable or potential? Okay? You cannot move them into the primary category. I'm not, look, everybody did this. You know, they also had a problem with Gorgon offshore Australia, right, or some piece of something in Australia that they had also declared as reserves. Companies have been doing this, you know, expecting to monetize it. But the accountants, that's how they do it. I want to avoid all this, and let's just talk about production forecasting. If you want to become a reserves expert, fine. You make $500 an hour, and you play golf 3 times a week, and you get to live at the petroleum plant. How's that? But you have to wear a 3-piece suit every day. And you have to go, that B factor looks a bit steep. Yes. So reserves is something that I don't do much of, but I do a hell of a lot of production forecasting. Production engineering. Natasha. You ever do artificial lift? Okay? You ever do liquid loading? You ever think about what you do in the field and how it affects us poor reservoir engineers? You can say no. You don't think about us? Okay. What about well stimulation? This is the weak link in shales. These two, how they connect. How much will the shale produce without stimulation? I'll give you a hint, 0. Okay? So your only way of effectively creating a communicating path with the reservoir and the wellbore is to stimulate it. Okay? Let's talk about stimulation for a second. We've been talking about injecting sand-laden water, or a mixture of gel, or even, I guess you could use diesel. Diesel's kind of out of vogue right now because of environmental issues, but it'd be the best thing to use. You use this, you crack the rock open. What's the advantage of cracking the rock open? You create a huge cross-sectional area. And when you crack it open in multiple stages, you create even more cross-sectional area. Okay, let's take it to the limit. Okay, let's crack it every 5 feet. That's not going to be economic. Also, what's going to happen is everything's going to go down the previous crack. Okay. What about using explosives? Or propellants? There's at least 2 propellants that are on the market. They're essentially solid rocket booster type materials that you would ignite, and it would create a slow burn, relatively speaking. It would create tens of thousands of psi. How much does an explosion create? Millions of psi, but it's in an instant, and it's completely undirected. Okay. Have we ever used explosives to stimulate reservoirs?
Tried to in Colorado.
Okay. We'll hold on to that for a second. Perforation, obviously, and there's variations of perforations that use these propellants. Pardon me. It's a Halliburton product line, but that's okay. Have we ever used nitroglycerin? They still do. In West Virginia, Pennsylvania, in shallow shale reservoirs, the Devonian shales, they would set it down there, and it would have a timer on it. And they said that the well would jump when it went off. And what happened to everything down there? Well, hopefully it got pulverized and created a cavity, which created a cross-sectional area, and it produced gas. This was before hydraulic fracturing. You know, you're worried about the environmental impact of hydraulic fracturing, and we're using nitroglycerin. So what did we do in Colorado? Quick.
They ignited like a nuclear.
Do you ignite a nuclear bomb? Yeah.
They detonated a nuclear.
Kind of like Bullwinkle, right? Light the fuse and run. Yeah. Yes. What was that name? It was Project Gas Buggy and Project Rulison.
I don't know the names.
What happened?
It basically destroyed everything and made it all
Correct.
radioactive.
The engineering was right. It just they sort of didn't really get the power of this thing locked in. What about other kinds of explosives? What about drilling herringbone wells? You guys know herringbone, like a fish? Yeah? Like that? That's been done quite a bit in Saskatchewan and southern Alberta in a really low pressure oil play. But what about stimulating that? That'd be pretty tough because the fluid's going to go in the path of least resistance. Why am I so fascinated by this? Because we only have one currency right now for shales. What is it? It's a multi-fracture horizontal well. Now you're going to hear some people that'll drill a lot of vertical wells and hydraulically fracture stimulate different sections like you do in Thailand. What's wrong with that for shales? It's not enough. It's not enough productivity. If you get 10 barrels doing that and you get 1,000 barrels doing the other, which one are you going to do? while you do the other. Then we talked about the phase behavior, and then last will be the reservoir modeling. So the reservoir modeling part will probably be kind of, I'm not sure how we're going to touch on that. You know, if I were gauging it, this part is the key. This part is important because it's going to determine how you exploit things. This part is just, how do you explain it, Paul? How do you explain reservoir modeling of shales to a group of students who probably have no interest in it? Everything that you've learned about reservoir modeling is that Darcy's law is valid, that phase behavior is easy, that things move from one direction to another, blah, blah, blah. And then this says, nope, that's all wrong. But what does the performance look like? It looks like Darcy's law. It looks like normal phase behavior. This doesn't bother anybody, right? Why?
As long as you're making profit out of it.
You'll do well. Okay? Last question of the day. What's the recovery in a liquid-rich shale? You drill a well, you complete it, you produce it, you make 100% of your money back, you walk away. How much did you recover? Rough guess.
3%.
3 or 30?
3.
3.
I have no idea.
Okay. Reasonable answer.
How many years?
Percentage. Oh, how many years?
Okay.
Let's say 50, something ridiculous.
30%.
30. Okay.
20.
5.
5. 15. 1%. Okay. Why 1?
You think it's would be lower than original
Okay.
with no.
If you do a really quick material balance on a black oil, and you look at only depletion due to compressibility, okay, what do you usually get? 5 to 7. Okay, that's approximately what we're looking at here. Probably somewhere in the 3 to 4 range. 1 would be a failure, in my opinion. Now, this assumes that we even know how to define what the oil in place is here. But our estimate is we're leaving 95% in the ground. Okay. So, who's going to start that oil company again? You're going to have how many wells right now in the Eagle Ford Shale do you have?
5,000.
Plus or minus, yeah, I think it's more like 6, but irrelevant. It's a lot. 3,000 a year, something like that. I mean, it's really ramped up. How many of them are in Mexico? 3? Okay. Does the play go into Mexico or does it stop at the border?
Across the border.
Yeah. Okay, so you got 6,000 wells now. You'll probably have 20,000 wells in 3 years. You know, whatever the end game is for the Eagle Ford, we don't know what it is. And you leave 95% there. Okay. How are you going to get it out? Let me throw you another bone. I know it's time to go. What's the single best liquid-rich shale in the world as we understand it right now?
Dakota. North Dakota.
The best liquid shale?
Liquid-rich, yeah.
North Dakota.
Think home.
Ah, Vaca Muerta.
The Vaca Muerta is apparently the best geological deposition. It's 700 meters thick in some places, but they are having a really tough time developing it. Who owns it? The Argentine government. Okay. And what did they do? They sold pieces of it, right?
Yes, I don't know what they do.
Did Tashin buy any of it?
Yes, everyone who owns a concession in that basin has Vaca Muerta. So
Okay.
most is YPF owned, 35-40%, and the rest is split in.
The rest is who?
Many companies.
Talking to you, it's like talking to my daughter, man.
Well, Total, the one I work for, Chevron, Pan American Energy.
Where's the map of the operators?
No, that's provinces.
Here it is. There you go.
Yeah.
See any familiar names? They're all there. Do you know what it's going to cost to develop the Vaca Muerta? The Argentine government estimate? More than $250 billion. What's the Russian shale? That's not the right picture. I don't know the name of it. Is this it? Yeah. It's like 1 million square miles. That's 2.5 million square kilometers. This thing's bigger than everything else put together. And who just bought into it? Big E. Okay. How many wells are in it? Probably a few test wells the Russians drilled, you know. These things are career makers. You're going to have, you go into unconventionals, I don't even want to think about where it could lead. But you have got to accept, you have got to start with the assumption that everything you think you know is wrong. If you think you understand phase behavior in shales, you're going to get hit in the back of the head with a brick. If you think you understand flow behavior in shales, 95% of this is left in the ground. How are you going to get it out? Not your problem, right? Whose problem is it? Yes, sir. You had a question?
It's just related to the course. Can I ask it right now?
Yeah.
So how is this going to work? Do you, with a video, are you going to...
What I'll do is I'll send you an email and say the class will meet. I'm going to try to do this every week like we had been. I don't want to abuse your time, but we may have to move to another night. Paul wanted Monday, Wednesday because he had a conflict. Term pond, sorry. And I've typically been on Tuesday, Thursday. When I'm in New Zealand, where my family lives, will be a day off. So it'll be opposite, which is fine. Shouldn't be any problem because it's sort of more or less afternoon. This time of year, it'll be noon or so other times. But it should be fine. I shouldn't have a problem. Usually the internet, I start having problems with it in the afternoon because people come home and we're at the end of the line, and, that sort of thing. But we should be okay for that. Now I've got some travel, and those are going to be tougher because I'll be off the time zone. It will be like 3 a.m. So I'm not sure I'm going to want to. I may make a movie, or I may just give you a self-study that week, But I'll start piling things into the library folder for you to review. And I'll provide some videos and some presentations and that sort of thing.
So for the regular class time...
You only meet if I tell you.
So we're not going to meet, for
You
example...
only meet if I tell you. It's very easy, Ali, in English. You only meet if I tell you, right?
Can Can I ask another question?
You just did.
Yes.
Go ahead.
I thought it's going to be a recorded video.
It is.
So we're not going to be able to talk to you. Because you said something
Okay,
on the speaker.
let me explain. When I tell you to be here, I'll either be here physically or I'll be through the computer. Now, you won't see me because I'm not going to waste bandwidth on video, but you'll hear me. And I'll control this and that if we want. Sorry, I wasn't meaning to be hard on you, but whenever I say we're going to meet, then I will be here. There will be a few occasions where he might be here instead of me. He'll log in, it'll be recorded, he'll go over something. There may be an occasion where I can find a good guest speaker, somebody who's really like a expert on the topic. The problem is getting them here may be a bit of a challenge. I could get them to do it remotely, but believe it or not, most people don't like that. They don't like talking to the computer. You've gotten pretty good at it. Other questions? Yes, sir.
For the project, are we going to suggest our own individual topics, or you give us a list?
I'm going to be more formal this time. The last two times, first time I let people do whatever they wanted, and that was pretty effective. There were only a couple of goof-ups, and that was one of the reasons I put the statement about, this is unconventional, low permeability systems. It's not Middle East water floods, and we did have a little misunderstanding on that. We fixed it. Last year went very well. Most people selected a topic, but I got different levels of depth. From someone who is really into their subject, I got a lot. From somebody who wasn't really into their subject, I maybe didn't. And you can look at the grades. I'm sure there's a distribution given somewhere. I expect you all to make an A, but there are people who didn't make an A. They are extremely rare, but the reason they didn't, and I can't believe I'm mentioning this, but either they didn't follow instructions or they deliberately didn't follow instructions. And that's why I'm being so careful in saying you have a paper, you have a presentation, you have a voiceover or a movie. That part's easy. The hard part is how do you construct it? How do you pick a topic? I want to be so excited about this that I can't sleep after reading your paper. That's how I want to feel. This is a moment where I define this for you. We're going to have a guided tour. Imagine we're on a hike. I'm going to show you this tree, I'm going to show you that rock, and then you're going to come back and you're going to study it and you're going to tell me about it. That's the way I want to treat this. If you're not interested in unconventionals, this probably won't be very much for you. If you're somebody who needs to have your hand held, it's probably not going to be very good for you either. I haven't had that experience yet, but and there's like half a dozen or more people taking it totally by distance, so they're only getting the videos. And those guys, if you're listening, they tend to do extremely well because it's something associated with what they're doing in their work life. The only thing I ask is be realistic. Don't take something from your work life, put a bow around it, and give it to me. Take something that you're interested in. Take some aspect of it. There's so much more I could say, but it's being recorded, and I want to be careful that I don't push you one way or the other. I want you to do something you want to do. If you want to study the GRI crushed permeability method, you're welcome to do that. I had a student do it. You don't want to see what he did because he completely re-derived it, reformulated the problem, and came up with a completely new solution, and now he wants to publish it. That's fine. I'm pleased, but that's not the purpose of this course. The purpose of this course is for you to say, okay, I want to study the Bakken. I want to explain to you why the Three Forks.
No, Three Forks is above.
Okay, but some people actually complete in the Three Forks or something like that,
Yeah.
right? Yeah. So I want you to explain to me why the Bakken has developed the way it is, what the potential is, why it was It's a typical high gravity, low GOR shale system. You know, why? Tell me something. You know, convince me that you know what you're talking about. You know, if you want to talk to me about pressure transient testing and how it's used, think about this. These wells have so many hydraulic fractures and they're so close. Guess what? When you turn this well off, it affects that well. When you turn that well on, it affects this well. Look, what's the best thing about petroleum engineers is they deal with uncertainty very well. They make decisions in the absence of definite information. If you know things are going to interfere, that's better than not knowing. Does everybody understand why? The biggest money dollar question in the industry, and I don't believe this is important, but let me rephrase it. It's important, but it is not the critical issue. It's well spacing. Why? Because at $10 million a piece, if I'm going to put 6, or if I'm going to put 8, or if I'm going to put 32, which is what Noble said they're going to do in the Niobrara, 32 wells per section. Okay? That's a hell of a lot of money. You know, well spacing is a critical variable. What is your layman's thought on well spacing? If wells interfere, bad, good, don't know. How about it from the pressure transient standpoint? Are they going to interfere?
I think so.
Why? Very quick answer. They have to. The hydraulic fractures have to hit each other. It's not Darcy's law then, it's Pazouillet's law. You have a channel extending 500 feet to the next well. You're not going to see a pressure response in days, you're going to see it in seconds. You know, you turn on well next to this one, bang, something happens. You know it's not hydraulic, or it's not Darcy communication, it's that. You know, there's a slit that connects the two. I want it to be your project. You know, I heard somebody say today that shale gas is uninteresting. And then I heard somebody say today that shale gas is all we're interested in. Two different companies. Why? If you're Saudi Aramco, do you care what the price of gas is? Why? Are you going to export gas if you're Saudi Aramco? What are you going to do with it? You're going to use it domestically because every molecule of gas that you replace oil is a molecule you can sell. How much more valuable is oil than gas? At least 4 times more valuable. So they stop burning oil to generate electricity. They burn gas, they use it for desal, whatever. It's more. So do they care about gas price, oil price, anything else? No. But if you ask a Marcellus operator why they're still drilling Marcellus wells, why are they drilling Marcellus wells? There's one simple reason: they have to. In this country, you have to hold the lease by drilling wells. In North Dakota, how do you hold the lease? Okay? But we have one section here, we have 2 sections here. What did the North Dakota government say? You have to have 1 well per section, right? Yeah, to hold the lease. Do you want to drill all these wells right now? No. You want to hold your lease, so you're going to put 1 well per section, right?
Yeah.
What if they let you drill 1 well for 2 sections? So instead of it being 5,000 feet long, it's 10,000 feet long. Look at the map tonight. There's a lot of 10,000 foot long horizontal wells in North Dakota. Because, huh?
And that is
Because it's cheaper to drill 1 long well than it is to drill 2 short ones. Right? Now, how much productivity do you lose with 1 long well? It varies, but it's probably, if you think you're going to get a multiplier of 2 and you get a multiplier of 1.6, 1.7, that's fine. If you get a multiplier of 1.1, then you probably want to rethink your strategy. Why would you get a multiplier of 1.1?
You wouldn't have lateral continuity with whatever horizon you're trying to
That's a fantastic answer, but give me an engineering answer.
Any change in permeability?
How far is a mile away from here?
How far is a mile away from here?
Yeah, just rough.
What do you mean?
I don't know. Pick a point a mile away.
I have no idea.
Okay. Pick a point in your house where you live, a mile away. Is HEB a mile away from here?
More or less.
Yeah. Is Kroger 2 miles away from here? The one down in Texas? Another mile down?
1.5.
Sorry?
1.5.
Yeah.
Whatever, okay? God, you're like my wife, all right? So you have a pipe, 4.5 inches in diameter, and it's full of fluid. And you have to push it 1 mile to get it to the wellbore, or to get it to a pump to pull it out. Or you have to push it 2 miles. See the difference? Yeah. And a lot of people are going to say, that's too simple, Tom. That doesn't really make sense. If you, I don't care. The reality is these undulating boreholes, they're not straight. They go up and down. So you're going to, and it doesn't really matter, but you're going to have a loss. You know, the likelihood of drilling a 10,000-foot well that makes exactly twice a 5,000-foot well is pretty small. The likelihood of drilling a 10,000-foot well that makes more than 2 5,000-foot wells is probably a geological phenomenon. Do we have those in the Bakken?
Geologic phenomenon?
Mm-hmm.
Yes.
And what's it called?
Partial field?
What do they think the good wells in the Bakken are from?
The lower Bakken. The red.
What's different about the good wells in the Bakken? And I don't know the geographic location, but it's sort of centered away from Montana,
West.
east, in the middle, sort of natural fractures. There's a local uplift. Yeah. EOG and Whiting found it. Other people were making 500 barrels a day.
Oh, El Cooley.
Yeah.
Kentucky.
Yeah. And they're making 1,000, 1,500, 2,000, 3,000 barrels a day. You know.
Yeah, okay.
If you've got a mile-long horizontal well and you make 100 barrels a day, do a quick guess at how much you're getting per second. It's nothing. It's like a thimble, you know. So, all right, I know it's time to go. All right, we'll talk again on Wednesday night. We'll cover some more, and I won't be all over the place like I was tonight. I'll be on top of the discussion topic more. But I want you to get a feel for 2 things. Number 1, be very engaged with this. I'm going to talk to you a lot. If you've got a question, I'm going to answer it. If I'm traveling, you know, the most it'll ever be is like 12 or 13 hours, maybe, well, it could be more than that depending on where I'm going. But, you know, I will answer your emails. I will give you guidance. What I'm not going to do, or I don't want to do, is I don't want to tell you what to do. You know, so if you tell me today, Preston, I know what I want to do, that's fine. I'm good with that. If you tell me today, I'm not sure what I want to do, then by March 1st, we're going to be sure. You know? Ms. Zhang, if you're sure today, that's fine. I hope you kind of change your mind or refine your view. And I am really bad about open-ended problems. I love open-ended problems. Who are you competing with in graduate school? Who? I've already told you, do what I tell you, get an A. So who are you competing against?
Yourself.
The mirror. So look yourself in the mirror and say, I'm going to impress this guy. You know, I'm going to keep him awake for a week after reading this. And not from pulling his hair out, okay? That has happened on occasion. You guys don't want to be around when I'm grading. My wife says I'm not a very nice person. But I want you to do your best. And this time we're going to try a different model. I'm going to ask you to show me things as you're going along. Any questions, thoughts, comments? Ellen, you okay? Yeah?
Are you putting everything on eCampus or is there anything else?
He's going to do that. I maintain my site, he's going to maintain the eCampus site, or him and the distance learning people will. If you want to talk to me, send me an email. That's my best advice. If you chat or Facebook or whatever, you're not going to find me. Yeah, I know I got a Facebook account. I made the biggest mistake. Oh, God. I reactivated my LinkedIn account. Oh, gosh. You don't have a LinkedIn account, do you?
I have one.
Do you? Do you know why I reactivated it? Because I wanted to find somebody's information, and that was the only way to get it. And it's like 10,000 people were waiting for me. Oh, God.
I deleted mine, and I still get emails saying people are pressing.
Well, when you haven't logged into it for 6 years, you know, you kind of hope it forgot about you, but it's like, no, email. And, you know, I'll keep in touch. Femi, you okay?
Yeah.
Okay. Waleed? Masaminos? Santero, you don't have a choice.
Okay.
Yeah, good. All right. Paul, you ready? Anything you want to say? You got to say something. Everybody likes him better than they like me. Because he's soft. He's the good cop, and I'm just evil. So, all right, get out of here. Go home. Do your thing. Don't mind me too much.
No, I'm gonna
You'll
enjoy
grow to
this
love me.
class. I'm sure I'll be good.
All right, see you soon. I gotta wait till this all shuts down. It's my thing.
So when is the first time we'll start to have these videos?
Oh, there'll be a video tonight. It's being recorded now.
What day will that be for?
Today, right now. It's being-
Oh, I mean like us in the course. Like when will you?
Probably next week. Although next week's really ugly because I'm still in the U.S., but I had made some commitments, and let me rephrase this. I will not be available. Actually, I'll make. Oh, but Monday's the day off.
Oh yeah, it's
Yeah.
MLK.
Okay. Yeah. I might do one for Monday, just to stay on track. I haven't done any where I haven't talked to the class. I don't like doing that because if it's short or something, maybe that'd be okay. But I like the interaction.
Yeah, because I thought you said that in the email you sent me. You said it was more like a self-guided study without lecture. So
I want to do it that way, but I also have this nagging desire
For
to make
interaction.
sure that I'm available. You
Yeah.
know, what happened last semester was that and I know this is being recorded, but I got really good responses, but the ones that were average or not what they
Maybe
should have been.
reviews.
No, the reports. The ones that could have been better were ones that needed more guidance, and I wish they had asked for it. Maybe I didn't make that clear to them, but they really should have. There were cases last semester that were a little disturbing as well, that people didn't spell check, they didn't do this, they didn't do that. I understand when English isn't your first language, but for these people, English was their first language.
Really?
Which really caused me to question how serious they were.
Yeah, as a grad student,